Algebra, the pragmatic approach to problem solving. Algebra is a form of math that came to Europe during the medieval period, yet it wasn't a new branch of mathematics. In India, mathematicians many hundreds of years before the current era had developed many of the concepts underlying algebra. Yet Europeans didn't know anything about algebra until they opened up significant mercantile trade with the Arab peoples during the medieval times. Many people today don't realize that for many hundreds of years, the Arab world had a far more advanced level of science and math than did Europeans, who, after the fall of Rome, entered a period we call the Dark Ages. As a result of their interaction with Arab merchants, much of the science and math that was lost had made its way back into Europe by the Arabs, and one of these was algebra. Encounter problems that require the use of algebra. But before algebraic methods were developed, people had to do a lot of guesswork in order to get the answers to some of the questions that they confronted. The purpose of this slide presentation is to advertise a free instructional book on the topic of algebra. Algebra, the approach to practical problem solving. In the link in the description section of this video, you will be able to download a book which is developed for students from the middle school ages to entry-level college. The book emphasizes critical thinking in interpreting and setting up problems, learning problem-solving methods and practice, providing numerous examples and step-by-step solutions. There are hundreds of problems to practice a wide variety of problems that you'll encounter. The next several slides provides an example showing the utility of algebra and the types of problem solving one will learn in the above book. Here we have a resort owner who has a riverside resort. This owner wants to increase the sleeping capacity his resort can accommodate. The area to be developed is 1/4 acre. A local safety ordinance requires the construction area to be fenced in if it's 1/4 acre or more. The owner has 100 yards of fence. If the area to be developed is rectangular in shape, what is the largest area in acres that can be enclosed by 100 yards of fence? In a problem like this, we have a number of things to consider. We have 100 acres or 100 yards of fence, but we don't know if it's enough to enclose 1/4 acre. Our area is rectangular, but we don't know which dimensions in particular specifically we need to make our fence enclose 1/4 acre, if in fact we can do it. So we introduce something we call variables, variable y and x, to represent the lengths of fencing on the sides of the rectangle. We treat the variables as if they were actual numbers and combine them with the information we do know, as well as the constraints of the problem, in order to determine what values of x and y would satisfy our conditions. So let's organize what we know. The area to be fenced in is rectangular, and the river forms one side of the boundary to be fenced in. Therefore, we need fencing only on 3 sides of the area. The sum of the 3 sides must equal 100 yards, because that's how much fencing we have at hand. The area of the rectangle is length times width, and we get that formula from a branch of math called geometry. So from this information, we can set up 2 equations. One involving the perimeter, which is we have the 2 sides, we have which we call y, y plus y, and the third side we call x. The sum of those three variables should equal 100 yards. So that's one of the constraints. Y plus x equals 100 yards. We can write that more concisely. On the right side, we see that we have 2y plus x equals 100. So that's one equation. The other equation is what we cited before, that the area, A, is enclosed, or the area A that is enclosed in the site is length times width. And we use A as a symbol or a variable for the area. And the formula is A equals x times y. So now we have two equations that describe the situation. We can combine these equations in such a way that we can determine what it is we want to know, which is can 100 yards of fence enclose a quarter acre? So if we put A, or the area, in terms of one of the two variables, x or y, we can try out different values of x or y and look to see what happens to the area. So let's try the area in terms of the length x. From the equation in A above, we have y equals 50 minus x over 2, and that was just simple arithmetic math that we solve for y in terms of x. And then we take that value and we put it into the area. So we have the second equation, which is A, or area, is equal to x times y. And we put in our substitution for y into that formula. So y then takes on the form 50 minus x over 2. And we multiply that out, and we come out with an equation for area, where A is equal to 50x minus x squared over 2. Now we have a formula that shows what the area will be for any given length of x, of fence in terms of the x direction. So that is a good thing. And we have the equation here, which is in a second order. What we mean by second order is that the variable x is raised to the second power. So A equals 50x minus x squared over 2. That's a second order equation. And what we can do with this equation now is we can create a table and put in values for x and see what happens to the area y. And from this table, then we can determine which value of x which will allow us to maximize the amount of land, and hopefully it's a quarter acre. So again, here's the picture of the area that we have. This is our problem. We have our equations here that describe the problem. We have our variables, y on two sides and x on the other, which gives us our rectangle, and the river is the other side of the area. Now, this is the table I generated. I made it into 4 columns so that it would present better on the slide. And the first column, we have the value for x going from 1 to 25. In the second column, 26 to 50. In the third, up to 75. In the fourth, to 100. We don't go over 100 because we only have 100 feet, 100 yards of fencing. It doesn't make sense to go beyond that. So what do we see the area, what happens to the area with the corresponding values of x? Well, we see in the first column that the area is increasing, and it increases all the way until x gets to 50 yards. Beyond 50 yards, we notice something happen. We notice that the value of the area begins to drop as we increase our length in the x direction. So for x equals 60 yards, we end up with a value of area that can be enclosed of only 1,200 square yards. That's 50 square yards smaller than the 50. So from this table, we were able to pick out a value of x equals 50 maximizes our square yardage at 1,250 square yards. So now that we have the values we want, we take a look at what the value of y should take. And we have x equals 50. We plug that into the first equation we had, which was for the perimeter. So we have 2y plus 50 equals 100. Then we just solve that equation and we end up with y equals 25 yards. So here's the situation now that we have solved for the different sides that maximize the area enclosed at 1,250 square yards. We have one side where x is 50 and the two sides where y is 25 yards. But does this meet our criteria? We don't know because the answer is in square yards. We have to convert 1,250 square yards into an acre. So we go to the internet, we find that 1 acre has 43,560 square feet. What we have to do then is convert 1,250 square yards into square feet. So we do this by multiplying 1,250 square yards by 9 square feet per square yard. And we end up with 11,250 square feet. That's how much area that's enclosed by the fencing, being 25 yards on two sides and 50 yards on one side. And we divide 11,250 square feet by 43,560 square feet, and we get 0.2583 acres. Now that's just a bit larger than the quarter acre. So we do, in fact, have enough fencing to enclose 1/4 acre, which would be 0.25 acres. So we can see here how beautifully algebra was able to analyze the problem, how we set up the problem, how we were able to calculate a maximum value for a given constraint, and we were able to be able to find out exactly what it was we wanted and what we asked in the beginning of the problem, which is, will 100 yards of fence enclose the quarter acre? So some takeaways from this: we have just experienced the power of algebra. And without this amazing branch of mathematics, an awful lot of practical problem solving would be at least difficult at best. It would involve a lot of guesswork. This slide presentation really wasn't meant to be instructional in any way, but it really was a demonstration of the power or utility of algebra and critical thinking. And we were given certain criteria and constraints of the problem, able to set up equations that defined the problem, and putting these constraints and the information and the equations of the problem together, we were able to formulate a solution. So I encourage you This is a free download. It is a book in draft. It wasn't completed until only a week ago. There may be a few typographical errors, um, but in overall, I think it's in pretty good shape. It's a 300-page compendium that is divided into 7 sections that all get to the critical elements of algebra. There's nothing extraneous. This book and the approach to algebra here is to reject extraneous jargon, and not to overemphasize certain aspects like factoring. I remember some courses I've seen where half the semester was spent on factoring. Factoring is important, but it's not it's not the end all or the end objective of algebra. Algebra is about critical thinking and problem solving, how to set up the problem and to find a solution. And so this book is developed with a specific philosophy that was in line with the approach that Dr. Charles Pine had taken in his when he taught and won his Professor of the Year, National Professor of the Year award for mathematics. So I hope that this is something that will encourage you to download and take the book, and hope it's a help to you. If you have any questions, contact me through the comments. I will leave my email address in the description section, along with the link where you can download the book. And again, I wish you the best.